Welcome to a world with AI. You know, we always talk about artificial intelligence like it's this magical thing that just lives up in the cloud. But today, we're going to pull that cloud apart and show you what's really inside. And spoiler alert, it's not abstract at all. It's a world of silicon and steel, and it has an absolutely massive appetite for energy. So let's just get this straight from the jump. AI is not in the cloud. It's in a factory, a brand new kind of factory, packed to the gills with millions of hyper-specialized computer chips. And these factories, well, they're running so hot, they're so incredibly power-hungry that they are literally about to reshape our entire global power grid. This is the real story of AI's physical cost. Okay, so let's dive right in. The spark that lit this whole fire is a frantic, behind-the-scenes hardware arms race. We're talking about a completely new generation of chips built for one thing and one thing only, to power artificial intelligence. And what's so wild is that the biggest companies are done just buying GPUs off the shelf. They are all in on designing their own custom silicon. I mean, just look at the specs for Google's new TPU or Microsoft's Maya 200. We're talking about chips with over 140 billion transistors, the fastest memory you can buy, and performance that's just, well, it's mind-bending. This isn't just an upgrade. It's a whole new kind of engine for a whole new world. And yeah, the experts are definitely noticing. This isn't just some small step forward. This custom hardware represents a fundamental leap in computing power, engineered from the ground up to run these colossal next-gen models like Gemini and GPT-5. The whole game is about processing more AI queries, doing it faster, and eventually doing it cheaper.
But what happens when you turn on millions and millions of these superpowered chips all at once? Well, the consequence is a thirst for electricity that is basically unquenchable. And this number really puts the scale of the problem in perspective. By 2030, data centers are projected to be eating up a staggering 12% of all electricity generated in the United States. Just think about that. That's up from only 4% in 2024. This isn't a slow ramp-up, it's a rocket ship. Let's bring this down to a personal level. Remember doing a simple Google search a few years back? It used basically no energy. But a single prompt to a powerful AI model today, it can burn through up to 60 times more power. Every single time you ask a chatbot a question, you're putting a way heavier load on our energy grid.
But here's the real twist. The problem isn't just that we need to build more power plants. It's about actually getting that power to where it needs to go. And this is where the whole AI revolution is slamming into a very real, very physical wall. And that wall has a name. It's called a binding constraint. It's not that we can't generate enough power. In fact, there are over 2,600 gigawatts of new energy projects. That's more than double the entire existing US power grid, just sitting in a line waiting to get connected. The issue is the grid itself. The transmission lines, the substations, the electrical highways are just completely traffic jammed. And this timeline just lays the conflict bare. A tech company can throw up a brand new city-sized AI data center in just a couple of years. But planning, permitting, and building the high-voltage power lines to actually power it, that can take a decade or longer. We're building AI factories way faster than we can build the roads to get fuel to them. So what do? Well, this huge problem is leading to one of the most drastic and, frankly, surprising reactions from the industry. Faced with a grid that just can't keep up, big tech is going all in on a massive direct bet on nuclear power. And you can't find a better example than what's happening at 3 Mile Island. Unit 1 was shut down back in 2019 because it just wasn't making money. But then Microsoft swoops in and signs a 20-year deal to buy literally all of its power. That provided the financial backing for a $1.6 billion project to fire that reactor back up for the specific purpose of powering its data centers. And trust me, Microsoft is not alone here. Meta has quietly become one of the biggest corporate buyers of nuclear power in history. They've lined up deals for up to 6.6 gigawatts. That's a mix of buying power from existing plants and making huge investments in next-generation reactor startups, like TerraPower and Oak. So this sudden, enormous new demand from AI, plus all these huge projects needed to meet it, well, it creates this unavoidable fallout. And that leads to a really critical question for pretty much everyone else. Right. As these AI data centers put this completely unprecedented strain on our regional grids, those costs have to land somewhere. And now they're starting to spill over to you and me, the everyday consumers. And look, this isn't some 10-year-out problem. It's happening as we speak. In the PJM region, that's the grid manager for 13 states and 67 million people, demand is just surging, almost all of it from data centers. And state lawmakers are already sounding the alarm bells, firing off letters that basically say, whoa, hold on, you better protect our residents from having to foot the bill for all these grid upgrades. And really, that brings us to the final and maybe most important question. This whole race for AI supremacy, it's not some abstract tech competition anymore. It has created a direct conflict between the speed of innovation and the cost of living for millions of people. And it forces every single one of us to ask, what price are we really willing to pay for this progress? Thanks for sticking with us. As you can see, the physical world of AI is incredibly complex, and it's changing by the day. If you want to keep understanding how this technology is truly reshaping our planet, make sure to like, subscribe, and hit that notification bell for our next deep dive, right here on A World with AI.